Up next, multiply without regrouping. Now, this is probably one that's going to go rather quickly. When they say without regrouping, that means that you're never going to have to quote unquote carry whatever, right? And that means when that happens, it makes the multiplication really easy. Notice right here, we've got 2 times 4,322, but this isn't really one big multiplication problem. It's actually 4 very teeny tiny multiplication problems. And because nothing is going to go over 10, we can just say, oh yeah, 4 times 2 is 8, 3 times 2 is 6, 2 times 2 is 4, 2 times 2 is 4. 4,322 times 2 is 8,644. When there's no carrying, it's really simple to do in your head. So don't reach for the calculator unless you need it. 11 times 9 is 99. Red balloons. 7 times 1001, same deal, right? 7, this is really just 7 times 1, twice. 7,007. 4 times 2, 12. Again, 4 times 2 is 8, 4 times 1 is 4, 4 times 2 is 8. 848. And if you are having a hard time keeping up with my multiplication here, that's totally okay. Remember that back in the kindergarten and first grade units, we did a lot of the times tables and a lot of different strategies that you can use if you are still struggling with the times tables. Memorizing the times tables is not necessary to be good at math. It can help certain things maybe be a little bit easier, but it is not necessary. 42 times 2 is 84. 1,010 times 6, again, nice and simple, 6060. So multiplying without regrouping is really easy, and it's a good confidence builder because all students have to do is remember how they multiplied one-digit numbers by one-digit numbers back in first grade, and it makes them, it sort of reminds them that they know how to do this. And now we're going to go ahead and take the next step and throw in a little bit of regrouping. Multiply with regrouping. Let's go. Okay, 2 times 4,555. There are so many different ways that you could do this, all right? Off the top of my head, here's what I'm seeing, okay? I see that I have 2 numbers here, 4,500 and 55. I don't want to break it all the way down into thousands and hundreds and tens and ones. That feels like a lot of work. Now that I have the patterns down, and now that I have this tool in my toolbox, I know that I can break this up however I want. And that's what I'm going to do, because I know that 4,500 times 2 is 9,000. What? And I know that 55 times 2 is 110. So instead of having one very large, intimidating problem, I broke it down into 2 smaller problems that I knew that I could do. Now, in 3rd or 4th grade, I would expect students to break it down further and maybe take up some space on a piece of paper as they work it out. But as they get better at it, they'll be able to find patterns like me that can, or like the one I just found, which can save a ton of time. So I believe we get 9110. Remember, any method that works, follows the rules of mathematics, and that can be explained coherently is valid and should be applauded. 7 times 414. See, this one I think I'm going to take all the way out because 7's a weird one. So I know that 7 times 400 is 2,800. All right. I know that 7 times 10 is 70. Notice that I'm not using the words hundreds or tens. I'm just going ahead and dropping the number. Again, that's because that's how I think best. And then finally, 7 times 4, which is 28. Add them up. I got 2898. And notice that when we break things up like this, often the addition part ends up being very easy. So I see 2,898 as an answer here. Next, 78 times 5. I bet I can do this one in my head. 70 times 5 is 350. 8 times 5 is 40. So our total is 390. That is not the only way we could have done that, though. I could have done, let's see. I know that 5 times 80 is 400. And then I could take 2 5s away to get 390. That would also work. Again, just trying to get thoughts going, all right? However you do it in your head, however you visualize it, is perfect. 2,821 times 3. Well, the good news is some of this is easy to do. So I'm going to split this up and make it 2,000 times 3. The ice cream truck is going outside my door. I am not going to run off of this stream and go get a SpongeBob. I'm not going to do it. Okay, 800 times 3. And then I think I can do 21 times 3. I don't think I need to break that one up. I know that's 63 and 2,400 and then 6,000. Make the big problems into smaller, more manageable problems. And that's a thing that is going to be a life skill that's going to go forward both in math and in the rest of the students kind of, in the rest of their life, right? Like, it's a very, very practical thing. So, we end up getting 8,463, it looks like to me. I didn't line up my numbers very well, but I'm pretty sure I got that right. I did indeed. Up next, 8 times 954. Ugh. Again, this one's a little bit intimidating, and I don't know why it's intimidating. Maybe it's because 8's a big number. I don't know what it is about this that makes me want to take it all the way out to its full parts, but I'm going to. And I'm going to say that 8 times 900, well, that would be 7,200, right? That's just one-digit multiplication. It means that we're taking this very complicated multiplication and turning it into just one-digit multiple. We're turning it into the times table again. 8 times 50, which is 400. Again, just because 8 times 4 is 40, just add a 0. And then 8 times 4, which I want to say is 32. Again, I'm not lining these up well. I should be better with, or I should be more neat about my work. There we go. 7,632 is our total. Again, being able to break these up and put them together is great. I would not belabor these problems too much. For God's sake, do not give your student like 500 multiplication problems to just sit down and crank out. You will kill their enthusiasm for mathematics and learning in general. Just don't do it. 7632. You can do this without busy work. Okay, 28 times 9. Well, 20 times 9 would be 180. And 8 times 9 is 72. Ooh, 72 and 180. 252 is what I see in my head. But I'm actually going to do this one out on paper because I'm not 100% confident in my process. 20 times 9 is 180. 8 times 9, 72. Okay, I was right. It is indeed 252. Just making sure it is no shame to double check your work before you double wreck your work. That sounded better in my head. Moving on. 9,508 times 7. It's even lined up nice and neat vertically. Let's zoom in on that. There we go. So I know that 8 times 7 is 56. In fact, I don't even need to put that 5 up there because there's a 0. 7 times 5 is 35. 7 times 6 is 63. Plus 3 is 66. The answer is 66,556. And with numbers this big, it's usually a good idea to just do a quick sanity check and make sure that it is in the realm of what it should be. Silverkey, you were asking before about the merits of estimating. Checking your work is one place where estimating is a great place to be. This is about 10,000 times 7, so our answer should be about 70,000. A little bit less because it's a little bit less than 10,000. Hey, look. We got an answer that's a little bit less than 70,000, which means not necessarily that we're perfectly 100% correct, but it does mean that we know that we're in the right ballpark. We're not going to end up turning in an answer that's blatantly wrong. 66556. Very nice. That is multiplying with regrouping. We are about a half an hour in. We are doing great, friends. Let's move on.